Ever wondered what it takes to breathe new life into a malfunctioning iPhone 7 or 7 Plus? Today, we dive into the world of iPhone motherboard repair and micro-soldering techniques. Think of the boot circuit as the heart of your iPhone, a complex hub of activity that ensures your device turns on and operates smoothly. Without key elements like the power supply, clock signal, and reset signal, your iPhone simply won't turn on. Starting with common issues, the first we will tackle is when your iPhone refuses to power up. You press the power button and nothing happens. The first step is to connect the phone to a DC power supply and check the ammeter. If it reads 0, proceed to measure the voltage on pin 13 of J4504. If it measures 1.8 volts, the power supplies for the boot process haven't been outputted from the power management unit, or PMU. The next step is to replace the PMU and test again. If the problem persists, it could indicate damage to the CPU or disconnected rails on the logic board. If, however, pin 13 of J4504 doesn't measure 1.8 volts, it's time to check components of the power button circuit, namely DZ4401, R4402, and C4401. If measurements show abnormalities, replace the corresponding component. If not, continue to measure the voltage on C1925. If this also lacks the 1.8 volts, replace the PMU. Sometimes, when dealing with power issues, it can be helpful to try to turn on the phone by connecting it to the USB power adapter. If the phone turns on, there may be damaged components in the power button circuit. If it still refuses to power up, the fault could lie with malfunctioning chips relevant to the boot process. Moving forward, let's delve into the VDD_main circuit. If the measured value of TP0408 is normal, it indicates that the relevant circuits of VDD_boost are also in normal condition. Then the won't turn on issue is likely related to the relevant circuits of VDD_main. Perform a diode mode measurement of C4200_RF. If the measurement value is abnormal, then the issue might be connected to the VDD_main circuit. In this case, a thorough inspection of the VDD_main circuit is necessary. Now let's pivot to a unique method for detecting faulty components when dealing with a large current issue. This method uses temperature and rosin to confirm the faulty component. Here are the steps. 1. Set the voltage of the DC power supply to 1V, then connect the phone with the DC power supply. 1. Gradually increase the voltage of the DC power supply. Meanwhile, touch the logic board with your hand. If there's a faulty component, the logic board should bear an obvious hot area. 1. Smear rosin on the relevant components in the hot area. The rosin on the faulty component should melt immediately, indicating the location of the fault. This method can help you identify the problem area quickly and efficiently, saving you valuable troubleshooting time. Firstly, we tackle a situation where the mobile device refuses to power up, and the ammeter shows a high current reading even without the power button being pressed. This suggests a potential leak in the logic board. In such situations, it could be that the BAT_VCC circuit is short-circuited. Start by checking the relevant circuit of BAT_VCC. Conduct a diode mode measurement of pin 5 of the battery connector J2201. If the measurement value of pin 5 is abnormal, the no power issue could be connected to the BAT_VCC circuit. In this case, a thorough inspection of the BAT_VCC circuit is warranted. However, if the value of pin 5 is normal, it indicates that the BAT_VCC circuits are functioning correctly. Next, continue to measure the relevant circuit of VDD_boost. Perform a diode mode measurement of TP0408. If the measured value of TP0408 is abnormal, the power problem could be linked to the circuits of VDD_boost. Here we need to conduct a meticulous examination of the VDD_boost circuits. If all the values measured so far are normal, it suggests that the issue lies with the relevant circuits of VDD_main. When dealing with large current issues, we can use a method that combines temperature and rosin detection to identify the faulty component. Here's how you do it. First, set the voltage of the DC power supply to 1V, then connect the phone to the DC power supply. Gradually turn up the voltage of the DC power supply. While doing this, touch the logic board with your hand. If there's a faulty component, the logic board should bear an obvious hot area. Next, you'll need to smoke rosin on the relevant components in the hot area. Rosin is a substance used in soldering that helps to prevent oxidation and improve the flow of solder. It also has a lower melting point than most components, which means it will melt immediately upon contact with a faulty component that's overheating. So watch closely. If the rosin on a component melts immediately, that's your culprit. You found the faulty component causing the power-up failure. In the next scene, we'll wrap up our troubleshooting guide and share some advice for your journey into iPhone motherboard repair and micro-soldering. C. The phone won't turn on. Connect the phone with DC power supply and press the power button. Current reading on the ammeter jumps to 200 mA and then stays still, which indicates that PMU got to work before the appearance of the fault. We need to find out the host area on the board with temperature rosin detecting method. C1. PMU is the hot component on the board. Check. The 16 rails of the power supply outputted from PMU if nothing goes wrong. Replace PMU if there is short circuit rail among them. C. 2 PMU is not the hot components on the board. Check relevant components of the hot area on the board and then replace the abnormal component. D. The phone won't turn on. Connect the phone with DC power supply and press the power button. E. The phone won't turn on. Connect the phone with DC power supply and press the power button. The ammeter reads between 60 mA and 90 mA. The fault is related to relevant circuits of PMU, CPU, or the NAND flash chip. First check if the phone can be recognized by the computer. E1. If the phone can be recognized, restore it via iTunes and continue the repair work with the help of iTunes error code. E2. If the phone cannot be recognized, try to replace the USB IC and test. If the problem remains unresolved, then fault might be related to the NAND flash chip. Detach the NAND flash chip from the board and connect the phone with the computer. If the phone can be recognized by the computer, restore it via iTunes and continue the repair work with the error code. If the phone still cannot be recognized by the computer, check working conditions of CPU list below 1 by 1. The 14 rails of power supply from CPU, the 32K clock signal, the 24M clock signal, the reset signal and relevant circuits of the I2C bus, common fault components of the boot circuit. To summarize, the diagnosis and maintenance of an iPhone 7 or 7 Plus boot circuit involve a systematic process of elimination, from checking voltage levels and component functionality to replacing the PMU and assessing the power button circuit. Each step brings us closer to pinpointing the issue and restoring the iPhone to its full functionality. Remember, patience and precision are key in this intricate process, so take your time and don't rush. With these tools and techniques at your disposal, you're well on your way to becoming a master of iPhone motherboard repair and micro-soldering. Stay tuned for more insights and tips from M10 Technology. And until next time, keep exploring, keep learning, and keep innovating.